Let's have a look inside of this 18650 battery charger. It comes with this battery here, which is 9900 milliamp hours. This battery is everything but this number here. So this is a fake battery. Let's have a look what it stands on it. Yes, do not dispose in fire or heat. Do not puncture, damage and disassemble. So you should not puncture it, but you should damage and disassemble it. Do not mix fresh with used batteries. So yes, let's have a look inside of this one. This has this Chinese American plug here. So connect the battery in here. And it says intelligence can be positive and negative. I've charged. I think they mean a negative here. That depends on which company you work for. Some companies use intelligence for a positive thing, and some companies use intelligence for a negative thing. So it's got the LED here. Pretty strange looking battery. So let's plug it in and see what happens. I've got this dodgy Chinese adapter here. Let's plug it in. And this is not going to the isolation transformer. So this will be live. Nothing happens. Is it some bad connection? Yes, here we go. Oh, that doesn't sound good. Don't want that to blow up in my face. Let's plug this battery in it. So yes, it actually does something. You see, the light is flickering a little bit. So yes, let's open it up and see how it looks like. It sounds of something inside of it. Some bits of plastic. Got one screw on the top here. And there's something under this sticker. Yes, there is. Let's remove the sticker. Actually, two screws under the sticker. Here we go. Oh, everything is coming apart now. I've got the plug. Here's the circuit board. Is that the main capacitor here? 400 volts, yes. Let's discharge that. Oh, look at that. You can see inside of here how close these two terminals are. This is for maybe the positive for the battery, and this is the negative for the battery. And when it's in place, it's just like 1.5 millimeters from disaster, shorting the battery. That's not good. Yes, here's a circuit board, not so many components. Here's the terminals for the plug. No SMD components. It looks like that it doesn't got any isolation distance at all. Let's have a closer look at it. Look at that capacitor. It's not even soldered properly. Look at that. The legs are just flapping around in the breeze there. Same with that pin here for a transformer. Can I just pull it off? Don't even need desoldering it. This is absolutely hilarious. Look at that. It says 470 microfarads. I put a 100 microfarad in here. And in here said 10 microfarads. But I have put in a 4.7 microfarad. Amazing. And the isolation distance goes here. Around this capacitor, which doesn't longer exist. Goes around here. Up here. And this way here. And the smallest bit here is right here. It's less than a millimeter. So I'm going to reverse engineer this circuit. You'll see how it looks like. Let's desolder the transformer. I will not use this transformer anymore, so let's just crack it open. So let's unwind it. We got this sticky tape on it. There's a couple of turns right there. Oh, look at that. That looks quite good for this transformer. That should be the auxiliary winding. Let's unwind that. 1, 2, 3, 10, 11, 12, 13 turns. And it's connected to those two pins. And remove the sticky tape. 1, 2, and it just came off. It's got another sticky tape here. So 1, 2, 2 turns of each. And this looks like the secondary. Let's cut that. 1, 2, 3, 10, 11, 12, 13 turns as well. So both the secondary and the auxiliary winding had the same number of turns. So now we should have the primary here. 1, 2, so that wasn't so much. 2 turns of sticky tape. And here's the primary. So let's unwind this one. 1, 2, 3, 171, 2, and 180 turns. Here we got the circuit diagram. Live and neutral coming in. We got no fuse, no interference filter, no full bridge rectification. Just one diode here, charging this capacitor, which fell off. Got this 1.5 mega ohm resistor for startup. Got the primary here, auxiliary winding. We got no snubber network protecting the transistor, and we got no interference suppression capacitor between those two sides, primary and secondary. So how this works, we got a little current flow here, partial turning on the transistor. Then we have current will flow here, making a change in magnetic field in this core here. That will induce a little current here. We run through this resistor, limits the current, and this capacitor turn the transistor fully on until this capacitor is charged up. And then it will turn off. The capacitor will discharge through here, through the transistor, and through this auxiliary winding. And the auxiliary winding actually senses the voltage here with this Zener diode. It's a 7.2 volt Zener diode. It's a special voltage for that. 13K resistor. So when the voltage here is too high, it will run through this Zener diode and the neutral. And on the secondary side, this is just straightforward. Got a single diode rectification, but this one isn't a high frequency diode or a Schottky diode. This is just a normal 1N4148 charging this capacitor, 100 microfarads, and then it goes to this chip here. Pretty interesting chip and a special package, HX3H1227, and got these two capacitors for stabilization. And this chip controls the current if it has a internal current sensing, and will light these two LEDs depending on if it's charging or if it's charged, a green and a red LED. So it's pretty simple circuit. And the conclusion about this charger, let's begin by the good things. It's quite small and it has a pretty good transformer with good isolation. But here we got the bad things. Let's begin here. We got no fuse, we got no fire protection, fusible resistor or anything. We got no suppression capacitor between secondary and primary, and the isolation distance on the circuit board is very poor, less than 1 millimeter, and the actual connection to the battery 1.5 millimeters from disaster, shorting the battery, potential fire hazard, and the internal protection for a circuit board, no snubber network. So by about a certain time this transistor will eventually get damaged. So what do you think? Is this actually a safe and reliable circuit? Hope you found this video interesting. Thanks for watching.